the first video, you saw how the ShotoLab system can control and monitor your mile high still. In this video, we'll show you the best part of the software, how you can analyze all the data of a run. Why is this important? Well, have you ever run a product and produced exceptionally good material and wondered why? Was it the feed product or the distillation process? Well, the ShotoLab software will allow you to answer these questions. First of all, to analyze your data, all you have to do is click on the Recall Experiment Data button, pick the file you'd like to analyze. It might take a second because of all the data saved during the run. And here's all the data saved during the run. Now this chart might look a little bit busy, but it's showing all of the data that was saved during the run. And it's easy to look at a particular item. Simply click on the Select Channels to Plot, and we're going to look at the column temperature profile. All you have to do is click on what you would like to see, hold the control button, and we're going to look at all of the column temperatures and click OK. And let's full screen this. And now you can see all of the column temperatures during the course of the run. Now if you look, you can see that the column top temperature stayed pretty consistent throughout the run. It was controlled using a PID. You could scale this actually to give a direct proofreading if you would like. That's another video. And for this run, we just wanted to get all the alcohol out. So you can see that the column wasn't run very efficiently. Most of the separation was done on the top of the column with respect to the temperatures. Here you can see where the midpoint temperature came down. We had a little more liquid in the column. Maybe it was a little flooded even. But the main thing is you can look back at this profile and compare it to another run to see if it made the product better or worse. Let's look at another interesting thing. Let's look at how we actually ran the column. This time we're going to look at our heat settings. We're going to look at the column pressure drop and then the amperages on our heaters and see how that affected the results. Now the pressure drop indicates how much liquid was on the trays of your column. If it was flooding or if there wasn't enough liquid on the columns. Now here you can see we turned the heats on and there was no pressure drop. The pressure was basically at zero and it didn't start to come up until about this point, and that's when it started to boil. We had liquid on the columns. At these places we were probably a little bit flooded, and you can actually compare this with your column temperatures, and we'll do that in a bit. But once we got the column stabilized, we ran at a pretty consistent rate throughout the run. You can see we stepped up the heat as the column continued the distillation process. As the alcohol was removed, we needed a little bit more heat to run it. And the nice thing about this is you can actually connect this column pressure to a PID loop, and that will maintain the right amount of heat to keep the column in its most efficient state. Again, that's something for a later date. Now, if you're fluent with Excel or other spreadsheet software, you can also have the ShotoLab system save the data to an Ascii file. This allows you to open the data in other programs for analysis. Now, I opened this in Excel, and here you can see all the data is tabulated from the run. And let's look at some interesting plots that we have. First, let's look at the column temperatures and the pressure drop in the column. This is an interesting plot. Here you can see we started out the distillation and the pressure drop was very low. Once liquid started coming in the column, the pressure drop increased. And at these 2 points, you can see the highest pressure drop. And at the same time, you can see that the temperature of the midpoint of the column went down. Now this is important because if the column midpoint temperature is lower, it means you have less water in that product at that point in the column. And water can be a big factor in carrying over flavors in the distillation process, whether they're good flavors or bad flavor. And this is especially important if you're distilling wines or if you want to do vacuum distillation. You want to make sure that your column profile is optimized to get the best possible product. Let's look at one more thing real quick. Let's look at the column temperatures with respect to the water flow going to the condenser. We had a flow meter connected to the input of the condenser, and you can see that when we started out we had the water flow at about 6 gallons per minute, and it stayed there between 5.5 and 6 gallons per minute throughout the course of the run. And we decided to reduce this towards the end of the run. And as you can see, we stepwise reduced this to about 3 gallons per minute. And the interesting thing is, even though we reduced our water by half, the column top temperature stayed basically the same. What does this mean? It means with the Lab system, you may be able to reduce the water you're using to your condensers by 1/2 or even more. In other words, you can save money and literally stop dumping it down the drain. These are just some of the things that the Lab software will do. As you can see, this system can help you get the most out of your mile-high stills and allow you to produce a consistent and superior product.